is about input and output impedances of current shunt feedback amplifier. Okay, first we'll draw the block diagram of current shunt feedback amplifier. Yes, the block diagram consists of an amplifier A and the feedback network beta. Okay, yes, it is current shunt feedback amplifier, means the sampling is current and the mixing is shunt. So we know the current sampling. Yes, this is the way of connecting to get current sampling. Okay, and you must indicate here the current I0. Okay, then the mixing is shunt mixing. For shunt mixing, the input must consist of current source. This is IS, and the feedback current is mixed in shunt like this. Okay, this is your IF because your feedback is negative. So if you observe this block diagram, input is current, output is also current. That is the reason this amplifier is a current amplifier. This is a current amplifier. Now the gain A is called AI, and the formula is I0 by II. Where is II? Exactly, the current to the amplifier is called II. Okay. So the basic amplifier circuit and the current shunt feedback amplifier is current amplifier. So now if you see beta, yes, what is the input for beta? Input for beta is I0. What is the output from beta network? IF. So what is IF? IF is equal to beta I0. Okay. So this is about the block diagram of current shunt feedback amplifier. Now to find the input and output impedances, we must draw its Thevenin's equivalent circuit. Yes. Let me draw the Thevenin's equivalent circuit. Yes, it consists of the source IS, a resistor Ri, input resistance Ri, and the output side also it consists of, means I am drawing first the Thevenin's equivalent circuit of the current amplifier and then I will include the feedback. Okay. So you know already the current amplifier Thevenin's equivalent circuit. Yes, this current is AI. R0 and RL. The current through RL is I0. Okay. So actually this is the Thevenin's equivalent circuit of current amplifier. But this is current shunt. You must include this feedback also. So if the feedback is negative, see here I am including the feedback and the input side. As the feedback is negative, you must draw the current like this. The feedback current in opposite to your source current IF. Okay. So what is IF? IF is equal to beta I0. Okay. So this is about your Thevenin's equivalent circuit of current shunt feedback amplifier. Now here is your RIF. Okay. What is RIF? VI by IS. What is VR here? This is your VR. So now we'll derive the RIF. Input impedance. Okay, so for the input impedance, you must start from input circuit. Okay, so if you observe the input circuit here, yes, IS is coming like this, and from this point, this is IR, and to this, the current II are flowing. So what is IS? IS is equal to II plus IF. Okay, yes. What is IF? IF is beta I naught. Okay. Now you have to replace this I naught. Yes. Now if you observe the output circuit, yes, II is coming here to this node, and then it gets divided into two parts. Yes. The current through RL is your I naught. So you can write I naught as, what is this? This is from input KCL, I can say. So this is from output. What is I naught? I naught is total current. Means you must take the current division there. Total current II into opposite resistance R naught divided by the sum of resistances R naught plus R. Okay. Yes, this is current shunt feedback amplifier whose basic amplifier is current amplifier. We know for the current amplifier R naught is high. Okay, so as R naught is far greater than RL, yes, you can neglect this RL and you can cancel these R naught and R naught. So what is I naught totally? I naught is II. Okay, so now if you substitute this I naught in this, yes, you are going to get IS is equal to, yes, II plus beta II. Okay, so it is II of 1 plus A beta. So now what is RIF? RIF is VI by IS. Okay, yes, VI by II of 1 plus A beta. What is this actually? A, not A, AI. Okay, then what is VI by II? VI by II is nothing but your RI. Therefore, RIF is RI by 1 plus AI beta. Okay. So, this is your RIF. RI by 1 plus AI beta. Okay. So, actual input impedance is RI. But with this current shunt type of feedback, the input impedance is decreased by a factor 1 plus AI beta. Okay. So now we'll see the output impedance. Okay. I'll see the output impedance. Yes. Yes, we must follow 2 points while finding the output impedance. What are those 2 points? If the source is current source, open it. And the second point, you must disconnect RL. Okay. We'll do those 2 things. Yes. Yes. Then I'll disconnect RL. At this point, I'll disconnect RL. Okay. Then I'll call this current as I, which is an opposite to I naught. Yes. And we know the voltage across RL is V naught, but as we disconnect it, just we name it with the voltage V. V and V naught are same. Okay. Then, if you observe this point, if you observe at that point, you are going to get R naught F, where R naught F is your V by I. Okay. Then write, yes, while finding the output impedance, you must start from output side. So, if you observe, to this node, the current I is coming. It gets divided into 2 parts. One is this side and a part is this side. So, okay. So, now if you write the KCL at that node, yes, I can say output KCL. From output KCL, I is equal to, yes, this AI is in opposite to the current I. Therefore, it is minus AI. Okay. Then to get the current through R0, you must go for voltage by resistance. So what is the voltage across R0? V. So it is V by R0. Okay. Yes, now we have to find what is II because it is the only parameter which relates with input. Now if you observe the input, we made Is is equal to 0 by opening the current source. Yes. Now if you substitute here, Is is equal to Ia plus If equation. As Is is 0, yes, you will get II, yes, what is this? From input, II plus If is equal to 0. Means II is minus If. What is If? Beta I naught. Yes, we know already If is beta I naught. And if you observe, I naught and I are in opposite direction. So as I naught is minus I, If becomes beta I. Okay, so now if you substitute beta I in this expression, you will get I is equal to, yes, minus AI beta I plus V by R naught. Okay, yes, now take I common. Yes, 1, this is 1 and this is AI beta is equal to V by R naught. Okay, so what is R naught F? Now R naught F is V by I, that is equal to R naught of 1 plus AI beta. Okay. Yes, this is your R naught F. Fine. So, in the absence of the feedback, the output impedance is R naught. But when you apply the feedback in the form of current shunt, the output impedance gets increased by a factor 1 plus AI beta. Okay. So, this is about input and output impedances of current shunt feedback amplifier. Okay. So, the conclusion is input impedance is decreased by a factor 1 plus AI beta and the output impedance is increased by a factor 1 plus AI beta. Okay. So, in the next class, I'll compare all the feedback amplifiers. Okay. Means their gains and their input impedances and their output impedances. Okay. Thank you.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.